I like to make a cursive M because it's 3 humps versus 2. Okay, so if I stop right here and multiply, what happens? Kilograms cancel. So now I'm left with moles of I2. Remember that mole fraction is actually a decimal. Don't leave it as a fraction, it's a decimal. Now that looks a lot like molarity, but we do have one different letter, and that is an L, molality. Now the symbol is a lowercase m. Remember, molarity was a big capital M. I like to make a cursive M because it's 3 humps versus 2 humps. Easy to remember there that way. The numerator is the same, moles of solute on the top, but on the denominator, instead of liters of solution, we have kilograms of solvent. So let's look at an example here. I've got sucrose in water, and so sucrose is my solute, and then the water is my solvent. Okay, so remember, the solute is little and cute, the solvent big as a tent. So the small one is the solute. So I've converted into moles of sucrose, and then to get the molality, all I need to do is take my moles and divide by kilograms. Well, I don't have kilograms, I have grams here, but I can easily convert that to kilograms. And then when we divide, we're going to get 0.400. Try to keep your sig figs intact. And then we can either say moles per kilogram or our symbol, the lowercase m, molality. All right, another problem. We've got some we've got to figure out what's the solvent and the solute. So the iodide is added to the CCl4. So this is my solvent, okay? And then that is my solute. So you've got to decide who's who in this case. Okay, so this time we know the molality of the solution, and we're trying to figure out how much solvent we put into this. So what I'd like to do is start with the solute. So I've got 100 grams. Let's convert that to kilograms. So 0.1, a whole bunch of zeros, kilograms of CCl4. And then I know the concentration is 0.480. Now watch how I do this. Instead of molality, I'm going to say moles of iodine, solute, per kilogram of CCl4. Okay, so if I stop right here and multiply, what happens? Kilograms cancel. So now I'm left with moles of I2. And then let's just use the molar mass here. We know there are 253.8 grams of I2 per 1 mole of I2. And so the units will cancel those moles, and what we'll get is 12.2 grams of I2. So it's just a formula. We're using, oh, that's wrong. That's not moles per liter. Moles per kilogram of solvent. And we want molality. There we go. That one's better. Okay. So moving right along. Not molarity, we want molality. Good. All right. Another one is called mole fraction, and this one's crazy. It's actually not a fraction, it's a decimal. I know. It's defined as the moles of a substance divided by the total moles in solution. So let's do an example of that. We've got a bunch of gases together. I've got oxygen and nitrogen and hydrogen all combined. I don't know the moles of any of them. I just know the masses. So what I want to do is convert from grams to moles. And this one we'll get 2 moles of oxygen, and then I've got exactly 1 mole of nitrogen, and then I've got 3 moles of hydrogen. And you're like, well, that's a little tedious. I know. The next thing we need to do, we've got to get, here's our formula up here. This one's correct. Total moles in this solution. So I like to stack them like this so that you can add them directly. So moles total, we've got, let's see, 6. Okay. Now to find the mole fraction of each one, what we're going to do, so the mole fraction of oxygen is the 2 moles of oxygen divided by the total moles, which is divided by 6 moles. And so that's going to give me 0.33. And then we're going to do the same thing for nitrogen. It's going to be 1 divided by 6. So that's 0.17. And then the oxygen, 3 divided by 6, which is 0.50. Now remember, these are called mole fractions. So this is the answer to this question. Find the mole fractions. Remember that mole fraction is actually a decimal. Don't leave it as a fraction, it's a decimal. And then if you add the mole fractions, the sum of the mole fractions is going to be pretty close to 1. So that's how you know if you've done that correctly.